Hi everyone, I hope you're enjoying my background screen as much as I do. Today's topic is projectile motion, and today's goal is to be able to analyze motion in 2 dimensions using kinematic equations. What is a projectile? A projectile is any object actually which is projected by some means and continues to move due to its own inertia or mass and is influenced only by the downward force of gravity. It can be an object that is thrown up, thrown down, thrown horizontally, thrown at the angle, as long as it keeps on moving and only the gravitational force acting on it, it is called a projectile. Simple, isn't it? Since a projectile moves in dimensions, it has 2 velocity vector components. One is the horizontal velocity, which is shown here in blue color, and you can notice that the length of the blue vectors is the same, which means that the horizontal component of velocity does not change. And the vertical component of the velocity, which is shown here in red or orange color. So we can see that the vector length of the vertical component of the velocity is shortening on the way up. It equals to 0 at the highest point and is changing direction and lengthening up on the way down. We also can notice that the length of the vector in the corresponding points of the parabolic trajectory is the same. The length of this vector pointing up is the same as the length of the vector pointing down. The result, and so the resultant vector is the sum of the both horizontal and the vertical component of the vectors. So this is the summary of what I just said, that the horizontal velocity is always constant, the vertical velocity changes due to gravity. Let's look at the projectile motion table that we're going to use for solving problems. We'll be dividing the page into horizontal and vertical components. We will have a dotted line, vertical dotted line in between, and we'll have a horizontal dotted line underneath, and the t time will be written under the horizontal line. The reason we are doing it this way is to separate the horizontal parameters and the vertical parameters. We are not going to cross them together because the motion in horizontal direction and in vertical direction is different. However, the time, which is this parameter, is going to be the same for horizontal and vertical motion. It is important to note that the acceleration along the x component is always equals to 0, and acceleration along the vertical component, y component, is always equals to g, which is in our case negative 9.8. However, we can choose it to be a positive 9.8 if we choose the direction of the vertical axis down. However, for our setup, we're going to choose the direction of our axis, positive y up, and positive x will be to the right. Let's look at the special of projectile motion, horizontal launch. For this case, the object begins the motion with the horizontal initial velocity, and for this case the vertical initial velocity is 0. For our table for horizontal launch, we're going to indicate that the initial vertical velocity is 0, and everything else, as we talked, as we mentioned previously, the AX is 0 and AY is negative G. Let's look at the example. A plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. At some point, the pilot decides to drop supplies to a designated target below. First question, how long is the drop in the air? Second question, how far horizontally from the point it was launched will it land? So here's our problem. Pictured for this problem, a plane is dropping a supply box, and that is the way the box will be falling, because initial velocity of the box is the same as the velocity of the plane in horizontal direction, which is v equals 100 meters per second. And that is what, so so the height y equals 500 meters, and the ground level is 0. So this is what we're going to show here in our table. Vx is going to be 100 meters per second, and delta y is going to be y final minus y initial. It's going to be 0 minus 500 meters. It's going to be negative 500 meters. To find the time of the drop, we're only going to consider the vertical motion. For vertical motion, this is the equation of the position. For the position, change of position, displacement y minus y naught is going to be equal to this part here, and from here we can find the time that the box will be falling will be equal to this formula. And after plugging in the numbers, we're going to find that the time is going to be equal to 10.1 seconds. For the second question, to find how far the box will move, we are going to find the x displacement in this delta x. To consider horizontal motion, and delta x is going to be equal Vx times t, and the time is the time that we just found. So after plugging in the numbers 100 meters and 10.1 seconds, we find that the delta x equals 1010 meters. Another example of the projectile motion we're going to consider is angled launch. For this situation, vertical velocity is equal to 0 at the top of the trajectory, which is right here. And projectiles launched at angle need to be broken into component vectors. So the sum of the vertical and the horizontal component will be equal to the initial projectile velocity at the point where it is launched, and at every point on the way of the trajectory. There are two more important things we want to know about the angled projectile motion. First is when an angled projectile returns to its initial height, right above the ground, its speed is the same but in the opposite direction. We can say that the vertical component is the same and horizontal component is the same, but vertical is in the opposite direction. And the second thing we want to remember, apply to solving problems later, that the time to ascend equals to the time to descend projectile motion. If the projectile starts and ends at the same height, so the time to go from here up is equal to the time to go from the highest point to the ground. Let's look at the example. A soccer player kicks a soccer ball with a velocity of 20 meters per second at an angle of 53 degrees. First, how long is the ball in the air? Second, how far away does it land? And third, how high does it travel? Let's look at these solutions one at a time. So for the angled launch, we keep on having our table for horizontal and vertical and for the time t. However, for the horizontal component, the initial velocity will be equal v cosine theta, and for vertical it's going to be v sine theta. And the picture we're going to consider for our situation is this one, with the velocity at the moment of the launch v at the angle theta to the horizontal. So that is how the object will be moving in a trajectory. This will be the highest point, and then it will be moving the same amount of time to the ground. So let's look at our solution here. So for horizontal, we have Vx equals 20 times 20, which is the initial velocity, remember, that's what we have, times cosine 53 degrees. And for the vertical initial velocity, we have 20 times sine 53 degrees. For the final vertical velocity, we have negative 20 sine 53 degrees, just because it is equal in magnitude but opposite in direction. For the horizontal acceleration, we have 0, and for the vertical, negative g. For the first question, to find how long the ball is in the air, we're going to use the equation for the velocity in vertical direction. We can find the time from this equation. When we plug in the numbers into the formula, we can calculate that the time is equal to 3.26 seconds. Question B asks us how far does it land. So we have to find the horizontal displacement, which is horizontal component of velocity times time that we already found, and when we plug in the numbers, we can find that the displacement is equal to 39.24 meters. So for the final question, we need to find how high it goes. So we need to find the height from the highest point to the ground at the moment when the object is at the highest point of the trajectory. So we have the same horizontal and vertical. We have Vx, Vy initial, and we have Vy final, which is 0. So that is how we're gonna find the height. We're going to write the formula for the vertical motion, and we can find that change of motion is going to be the difference of the velocities, and we plug in the numbers. We can find that the change of vertical position or the height is going to be 13.02 meters. Please fill out the Google form with other questions that I have for you for this topic. Thank you for watching.